All right, so today's agenda. I've got some announcements quickly to make, and then I want to touch on the following topics. So variables in Java, so they're quite different than how variables work in Python. Primitive versus reference types. Again, there's a big difference between Python. Identity, which you may or may not have learned well or at all, I suppose, in your previous course. It turns out to be absolutely critical in both Python and Java. And then finally, I want to talk a little bit about integer overflow in Java, because this is something that happens in Java that does not happen in Python. And then at the end, I'll take any questions related to either the week 1 or week 2 readings. Okay, so announcements. Assignment 2 will be released soon. By soon, I mean either tomorrow or Friday. I think I have it misplaced. I think I have a assignment 2 thing in this week. The intent was to have it released next week, but that's fine. I'll release it this week. I have to remember to open the discussion forums. So I want a set of forums for each week where students can post questions about the readings and assignments. Other students, if you know the answer, I encourage you to give the answer. The TAs and myself will endeavor to try to answer questions within a day or so of when they're posted. Yeah, there could be some lag because I know there are students who are basically overseas somewhere, and so they might be posting questions at 3 in the morning, which we won't be answering at that time. All right, so let's get started. Variables. So there's a big difference. So if you've been doing the readings, and hopefully you have been, you'll have noticed right away that there's a big difference between variables in Python and Java. Right? So in Java, a variable always has a type, right? So it has a type and a name. And you have to declare the type and name before using it in Java, right? So you know in Python, you can just write something like x equals 1, 2, 3, 4, and away you go, right? In Java, you have to declare the type of the variable. So the value 1, 2, 3, 4 looks like it's some kind of integer value. So the default type you would use for integer values in Java is usually int. So you would say something like int x equals 1, 2, 3, 4, semicolon. The semicolon is the other big difference between Python and Java. Most statements in Java need to end with a semicolon. Okay, so that's the big difference, right? You have to declare the variable first, and you have to declare both the name and type before you can use it. Right? Once you declare a variable, well, I'll leave that for now. Right. Okay. In Java, the type of the variable cannot be changed once it's created. And a variable can store values only having a compatible type, right? So you know in Python, you can write something like x equals 1, 2, 3, 4, and then on the next line, x equals the string hi, and everything's fine, right? And that's because in Python, variables don't have types, right? There's no type associated with a variable. In Java, once you make the variable x, then you can only use the variable x, in this case, to store an int, right? So int x equals 1, 2, 3, 4. You're now stuck with x as being an int, right? So if you try to do x equals the string hi, you end up with an error, right? And you know, I'd encourage you to try these things out either in the Jupyter notebooks or in Eclipse, right? So I'm going to take a quick I'm going to take a quick moment to show you how to use Eclipse in case you haven't watched the video yet. So in Eclipse, I've already got this Java project called CISC124, right? You can see I've already got a package called week 2, right? I want to show you how to get rid of this project because it's something that you might want to do, and it's not exactly obvious how you do it, right? So for example, suppose you created a project called, I don't know, junk or something like that, and you wanted to get rid of it. Then the way you get rid of it is you, in the Package Explorer, click on the project and then right-click, right? And then go to delete. Right. For a project, there's this box here, right? So there's a box here that says delete project content on disk cannot be undone. Eclipse is trying to tell you that when you delete this thing, it's going to delete the files associated with the project, right? And often that is what you want to do, right? Sometimes it's not, but often it is, right? So for example, if you download the a project associated with an assignment, right? And you later you decide that you've done a bunch of stuff, like you screwed up a bunch of stuff, and you want to get rid of it completely. If you don't click this box, right, it won't remove the files from disk. So when you try to import the project again, it'll complain the project already exists. Okay, so when you delete a project, you normally want to click that box, right? If you don't click the box and you try to create a project with the same name, Eclipse won't let you do it. Right, so I'm going to nuke the project, and now I'm going to go back and show you how to make a new project. Right? So to create a new project, it's new, Java project. Hang on, if you don't have that option for whatever reason, you can always get to it from the project menu. And here you just click Java and then Java project. Next. Give the project a name. So I'm just going to create a 124 project. For random 124 stuff. Whenever I give you a project for an assignment or a quiz or whatever, I'm always using Java 1.8. You can change it if you want to. If you change it to something higher, it complicates some things. So I'm going to show you how to deal with that too. So I think I have Java 11 installed. So I'm going to use Java 11. Next. If you use something that's not Java 8, so anything higher than Java 8, uncheck this box here, the create module info Java file. If you leave it checked, you're stuck with Java modules, which is a feature that was brought in Java 9. We don't use those in this course, and it creates some complications, especially for new Java programmers, because now you have to deal with this whole module organization structure. That you don't have to deal with if you're using Java 8. So uncheck that box and finish, and away you go. Okay. So now you can click on that little arrow, and you can go to the source folder, and now you can create new packages and new classes. I'm going to make a new package. You don't have to, but I'm going to make one called week 2 just to show you how to do it. Okay. And then in the week 2 package, I'm going to make a little file. So this is what you should be doing if you want to make a little test program, right? So you make a class in Java, right? In Java, everything has to belong in a class. Well, to run a Java program, you need at least one class. Let's put it that way. So I'm going to make a new class. You give it a name. I'm going to just call it week 2 for now. You can call it whatever you like. Java class name should always begin with a capital letter. Okay. And here I want to have something that can run, right? So I want to have a class that I can press the run button and something will happen. You want to check that box right there, right? You want a public static void main method, because every Java program that runs, that you can run, has to have a main method. Click finish. And then Eclipse will generate the skeleton of the class for you, right? So there's your class, there's your main method. Right, there's a comment that says this is just an empty main method for you to do whatever you want with. And what I wanted to show you was what happens when you type something like this into Eclipse. Right, so I'm going to make a variable x. I'll use 1, 2, 3, 4. Right. I'm going to save that. So Control S. If you run it, Eclipse will compile the class. Down here will be any output if there's any output. This program doesn't generate any output, so nothing happens. Everything's fine. Right? If you want to, you can print out the value of x. Right? System x. Right? This is the other big difference between Java and Python. Right? Java is known to be or said to be verbose. Right? You have to write a lot to get it to do a little. Right? In Python, you would just write print. Java, you've got to do system out print line. Right, there you go. Okay, now, if I try to do x equals hello, right, you'll notice that Eclipse tells you there's an error, right? If you ever see a red in your editor, there's a problem, right? Big X up here, big square here, big red thing here, big X here, right? Eclipse is waving at you, trying to tell you, hello, there's a problem, right? If you hover over the error, Eclipse will try to tell you what the problem is, right? And so here it's telling you it can't convert the string, right? So it can't convert the string hello into an int, right? What it's complaining about is you said x was an int here, and you're trying to put a string into an int, and you can't do that in Java. You can do it in Python because Python variables have no type. Can't do it in Java because Java variables have a type. Right, so I cannot put a string into an int, so can't do that. So if you try to run this, it'll complain again, right? And you'll get this exception, right? Unresolved compilation problem. So it's telling you Eclipse can't compile this program. Type mismatch cannot convert from string to int. And it even tells you where, right? It tells you on line 8 where the problem is. Right? So whenever you see something like this, you should read the message and try to understand what the problem is. Right? So I can't do something like that. So I have to get rid of that. All right. Any questions so far? If you have, oh, someone's got a question in chat. What's going on here? Whoa, a lot of questions. Sorry. Hard to convert. Is it hard to convert an int or double into a string? Is it hard to convert an int or a double into a string? The answer is no. I haven't asked you to read the string notebook yet, but if you want to, string s equals. So you want to convert x to a string. So there's a bunch of ways to do it. One way is to write that. Sorry, x. Right. So in Java, you can use the plus operator for strings, right? And what that does is it joins strings together. So if you start with a string, right, a string plus anything will take the anything and try to convert it to a string. So it'll take the number 1, 2, 3, 4, the int 1, 2, 3, 4, and produce the string representation for it. And then it'll join them together. So that's the empty string joined with whatever the string representation of x is. So that works, right? You can use the string class to use the method value of x. That also works, right? We can print them out. I can't type today, sorry. S and T. This should print out 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Now, you also asked, do I know an IDE that'll make coding easier in Java for Python used by Charm and often fill in the blanks? Guess what? Yeah, I mean, Eclipse does that too. Eclipse has auto completion. If you want, you can use, well, what is, who makes, it's JetBrains. They have an IDE for Java too. I forget what it's called. They have an IDE that's similar to PyCharm. Yeah, there you go, IntelliJ, someone answered, there you go. You can use IntelliJ if you want. I'm assuming everybody's using Eclipse, so because I can't support many different types of IDEs. You can simply use the toString call. You cannot use toString on an int because it's not an object, right? Can't use toString on an int. You can use toString on an integer, big I integer, can't use an int. Use Vim, do not use Vim. As a new programmer, do not use Vim. Also, we can get JetBrains. Yeah, there you go. Thank you. I'm looking for this. Eclipse is not my vibe. Can you reassign the variable to be a? Can you reassign the variable? No, you can't reassign the variable to be a string. You can't change the type of a variable. So x in this method is forever an int. Right? Now I can make another method. F. And here I can make a string x. That's fine. Right? There's no problem with doing that. So Java has this thing called scope, right? So the scope of the variable x is the block that it's defined in. So a block in Java begins and ends with these braces, right? So inside this block, x is always an int. Outside of the block, you can redeclare x to be something else. So you can do that. Can you do integer toString x? Probably. Integer toString, I think it's integer value of. It's not integer toString. I don't think it's toString. I don't remember all of the APIs, but you can always look it up. It might work. To string, is it here? Oh, it is here. Yeah, it works. That works fine. Okay. Any other questions? Capital I integer is an object. Actually, capital I integer is a class. It's not an object. As long as you're on this topic, here, class, big I integer. Inside the class is a method that's static. So static method in Java, you call with the name of the class. So big I integer is a class, not an object. When coding, is it good practice to have a main function that calls other functions? Well, if you have a Java program, so a program that actually runs, it has to have a main method. That main method typically makes objects, and those objects will call methods on other objects. Does instantiating a public string extend its scope to other methods? No. Well, you're confusing a bunch of things right now. Inside of a method, you can't use public. You can't call a variable public or private or whatever, right? You can have what's called a field that's public, but we're not going to get there for several weeks. Okay. Any other questions? Okay, good. Right. So I would encourage you to either use the notebooks to try pieces of code, right? Or fire up Eclipse, make a main method, and try it there. Okay. Primitive versus reference types. So in Python, everything is a reference type. I don't know if you've been told this, right? So everything in Python is an object. In Java, that's not true. Java has two different types, two different kinds of types. There are the primitive types. They always begin with a lowercase letter, right? And they represent numeric values and true-false values. Right? So the 8 primitive types are right here: byte, char, short, int, long, float, double, boolean. Boolean is true-false. Byte, char, short, int, and long, those are all integer types. Char represents characters. So they look like letters. In Java, they're actually treated as numbers. And that's explained in the char notebook that you'll get to this week, I think. For the primitive types, normally you're using int and double. Sometimes you're using long. For floating point or decimal values, it's almost always double. It's a little unusual to use float unless you have a good reason to do so. Right, so usually you're using int and double. So for integer values, it's normally int. It's normally double, unless you have a good reason not to use int or double. Right. For things like characters, it's char. Right. It's unusual to use byte, short. Less unusual to use long. Okay. Everything else, right? Anything that's not one of these 8 types is a reference type. Okay. So for example, string, big S string is a reference type. Big I integer is a reference type. Right. So everything that's not one of those is a reference type. So what's the difference? Python does not have primitive types. Right? So when you make an int in Python, so if you say x equals 1, 2, 3, 4 in Python, you're actually making an object that represents the integer value 1, 2, 3, 4. In Java, that's not true. If I say int x equals 1, 2, 3, 4, then the variable x actually stores the value 1, 2, 3, 4. Okay? So every primitive value occupies a fixed amount of memory in Java. Right? The different types occupy different amounts of memory. So an int takes up 32 bits. A double takes up 64 bits. Short and byte and char, short and byte are, no, byte 8 is 8 bits. Short, char are 16 bits, and so on and so on. So they all occupy different amounts of memory, but they're fixed. So this is the important part that you have to remember. It's a fixed amount of memory. Okay. If it's a primitive type, the variable stores that value, right? So if you write double y equals 1.0, and then the value 1.0 is stored in the variable y. Okay. That's not true for the reference types, right? So a reference type, reference value occupies a fixed amount of memory as well. Okay. But all reference types occupy the same amount of memory, right? So, sorry, all variables of reference type occupy the same amount of memory. So the question is what does a reference type variable store? Right? It does not store an object. And this is true in Python, right? So whatever, if you were taught this in your previous Python course, it's also true in Java, right? A variable of reference type stores the identity or the memory address of an object, right? So when you write string s equals double quotes hi, right? There's some string object that corresponds to the letters hi, right? So there's some object in memory that represents the string hi. The variable s is the address of that object. Right? So the value of s is the memory address of the string object. Right? Now you can't, as a programmer in Java, you can't do anything with the memory address, right? So if there are any C or C++ programmers, you know you can do all sorts of crazy things with pointers. You can't do any of those things in Java, right? You can't do any of those things in Python either, right? So the memory address is just some number, but you can't do anything with that number. So as a new programmer to Java, don't worry that it's a number, right? Just think of it as a memory address. Okay, so Mohammed had a question. He asked, so using the different variables allow you to minimize the memory use of your program? Yeah, so that's one reason why you would pick float over double, for example. So if you have a program that has a huge number of floating point values, then you might consider using float over double if you're worried about the amount of memory your program is consuming. The trade-off is, well, there are trade-offs associated with that. So floats can't store the same range of values that a double can. But that is, yes, but Mohammed, that is one reason why you might choose a type that uses less memory. Okay, so reference type stores memory address. Primitive type stores the value. All right, this is absolutely critical. Right. Okay, identity. So what is meant? So back here I said it stores the the identity. Okay. So the identity of an object is just its memory address. So in Python, when you write x equals single quotes hello, right? What does that mean? It means you make a str object, so that's string. String object representing the string having the characters HELLO, right? So x equals hello, make a new string object. Its characters are HELLO, and then x stores the identity or the memory address of that object, right? So it's the
Professor, you're muted.
Sorry, how long have I been muted for? Since here?
Just a few seconds.
Oh, weird. Okay, let me go back. Okay, identity. So in Python, when you write x equals the string hello, right, that means make a string object that represents the string hello, right? So the sequence of characters HELLO, and then store the identity address, sorry, the identity or memory address of the string object in the variable x, right? So variables in Python are exactly the same as reference variables in Java, right? Okay, right. So in Python, right, a variable is a name that refers to an object, right? So there's an analogy that you can use if this isn't clear to you, right? So imagine you have a friend named Maya, right? So this is the person Maya. That's the name Maya, right? They're not the same thing, right? The name of the person is not the person, right? The name of the person refers to the person Maya, right? So in Python and in Java, right, anything that's a reference type is similar, right? So when I write x equals hello in Python, the name x refers to some object in memory that is the string hello, right? And that's what this arrow means, right? So x is not storing the object, right? Maya is not the object, right? X refers to the object, right? Maya refers to the person Maya, right? And that's what we mean by a reference, right? So X is a reference to an object, right? And a reference is just a memory address. So X stores the memory address of this object here, right? It's the same thing in Java, right? String X equals the string hello, right? Double quotes in Java, right? Means the exact same thing. You make a string object representing the string hello, assign the address of that object in the variable X, right? So it's the exact same picture, right? X refers to this string object here, right? X is not the object, right? It refers to the object, right? So if you write string X equals hello and then string Y equals X, what does that mean, right? So that means, well, it means the same thing for string X, right? Make a string object, right? Assign the identity of the object to X, right? So X is the address of the string hello. Y equals X means assign the identity of X to Y, right? So in other words, X is the address of hello, of the string object hello, and Y is now the string address, is now the address of the same object hello, right? You did not make a new object in this case, right? X and Y both refer to the same object. So how could you create an alias? That is an alias. It is an alias. This is exactly an alias. It's the exact same thing in Python. X equals hello in Python, followed by Y equals X, is exactly the same. X and Y are aliases, right? They are just different names for the same object. So that's what an alias is, right? In Python, back here, X equals hello, Y equals X is the exact same thing. X and Y both refer to the same object. Right? And now the picture looks like this, right? So X refers to that object and Y refers to that object. Right? They both refer to the same object. You did not make a new string object in this case. Right? This notion of identity and references is very important in both Python and in Java. The problem in Java is Java gives you the two different types. So they give you primitive types and they give you reference types. The problem is you need to always remember what is the type that I'm working with because they behave differently, right? Primitive type stores the value. A reference type stores an address. Right? So you have to always be aware of the difference. Okay, any questions so far? This is only for reference types such as strings. It would be different with a primitive type such as, yeah, so for a car, what would the picture look like? Okay, let me duplicate the site. Okay, so what do I want to do? I need this one too. Okay, car. Oh, I mentioned earlier already, I can't type today, it's very bad. Okay, car is just a single character in Java, right? You use the single quotes. I guess that's the other thing you have to be aware of. Single quotes in Java means car, right? So is the car literal, right? You can't, don't confuse it with the Python string, right? Okay, so what does this mean? Well, car is primitive. So, oh, hang on, gotta let somebody in. Okay, so this means store A in the variable X. Okay, the next line means store the value of Y, of X and Y. But the value of X is the car A. So car Y equals X means store a separate copy of the car A inside of Y. Right? So the picture here is different. There's no references, so you get rid of the blue lines. And X, what do I use here? X is A, Y is also A. Right? So in this picture here, the value that you store in X is the character A, and the value of the character, the value that you store in Y is also the character A. But there's two character A's in memory here. Right? Back here, well, there's only one string object in memory. Right? With primitives, you end up copying the value of the primitive. Why would you use a different variable name for a car? Why would you use a different variable name for a car? Well, I mean, you might need, back here, I mean, you might want to do something like swap, right? So you might have two cars that you want to swap, so you're going to make a temporary variable Y that stores one of the values. Right? Okay, if someone were to change X, would it also change Y? It depends. For the car example, the answer is no, right? So if you then write, let me duplicate this side. And I'll take it down here. Car, oh, not car. Y equals Z. Right. Store car in the variable X, store the value Y, but the value is just, okay, and then it means store the car Z in Y. Right? X has not changed. X has not changed. Right? Y would not just reference, no. Primitive types are different, right? Primitive types, right? This is why, it's a good thing I went over this, right? Primitive types, the value, a variable primitive type stores the value, right? It does not store a reference, right? So when you're working with primitive types and you write stuff like this, right? Y and X here, they're not referring to the same piece of memory, right? They're not referring to the same piece of memory. So beside X in memory is the value A, beside Y in memory is the value. Where'd he go? Someone was trying to get into the lobby. The value stored beside Y is also the character A, right? On the next line, you're going to erase A and replace it with Z for Y, but X is still A. Okay, and that's why, right? That's why I reviewed this, right? So the way primitive types behave in Java is not what you're used to in Python, right? So you have to be clear on what's happening. Okay, any other questions? Super. Integer overflow, another weird thing that happens in Python, in Java that does not happen in Python. Okay. Now, I told you a few slides ago that every int occupies a fixed amount of memory, right? It's finite, it's fixed. Is this slideshow? Yeah, I'll post it. I'll post it, Roar. The video for this will also be posted, okay? The fact, right, so every int or every primitive type occupies a fixed amount of memory, right? So if an int is represented by a fixed amount of memory, right, that immediately implies there has to be some maximum and minimum value that I can store, right? Because you have a finite amount of memory. I can't represent an integer that is infinitely long. We tested, yeah, you know about the maximum values in the assignment, right? Sorry, I just lost my train of thought. Oh, okay. So you know that there's a finite range of values that you can store in an int, right? And that's true for double and every other primitive type, right? Now that's really different compared to Python for int, right? So ints in Python are limited only by the amount of memory you have, right? So in principle, you can store an int having enough digits to occupy however much memory you have on your computer, right? And so that's really very, very different. Now, because the range is fixed, whenever you do arithmetic, whenever you do arithmetic with a primitive type, right? If the operation causes the value to exceed the minimum or maximum value, then we say overflow occurs, right? What happens is the value wraps around the other side of the range, which is very strange. There is not then a max length string in Java. Again, yeah, so strings are limited in length. Actually, that's not true. So the length of a string is, the maximum length of a string in Java is 2 to the power 32 characters, because the size of a string is defined as an int. So 2 to the power 32 number of characters. An alias can be made for reference types by using the assignment. Yeah, so whenever you use the assignment for reference types, you get an alias in Java. That's right. Okay, now this is very strange. So here's a picture. So the picture, there isn't a picture in the notebook. Instead, there's a number line written with numbers, but a picture looks like this. So here's the blue bar here represents the range of int values. Right? So the most negative int value is integer min value. The most positive int value is integer max value, right? And so that's the range of ints. If I go past this end, right? So if I do integer max value plus 1, it comes all the way around back to integer min value, right? Which is weird because that's not how math works, right? So, for example, I'll just use x again. So x equals integer dot max value. Y is equal to x plus 1. And now I'm going to print out y. You know, I'll print out x as well. There we go. Okay. So if you run this, there's x, right? That's the most positive value. If you add 1 to it, well, you would expect the value to still be positive, but it's not. It wraps around to the other side and you get a negative value, right? You get the most negative value, right? Okay, everybody remember this value. It ends in an 8, right? If I add 2, right? It wraps around and keeps going. So I'm now at minus 2, blah, 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 7, right? So I'm not at integer min value. I'm at integer min value plus 1, right? If you add 3, right, remember this is a 7, this is going to change to a 6, right? So in the picture, I'm not at integer min value, but I'm at integer min value plus 2 more, and so on, and so on, and so on, right? Similarly, if you're at integer min value and you subtract 1, so I go this way past the end, it comes around to the other end, and you end up at integer max value. Again, in Eclipse. Change this. Now I already declared y, so I can't declare y again, so I just have to do that. So x minus 1. Okay, so I'm going to get, there's integer min value. Add 1, you end up at integer max value, right? If you subtract 1, sorry. You subtract 2, you end up at integer max value minus 1. So that's going to become a 6, right? Subtract 3, that'll become a 5. right? And so on and so on and so on, right? So in other words, you go around this side and then you keep on going this way, right? I don't see the compiler working. Yeah, the compiler is working. Whenever you press the play button, the run button, Eclipse automatically compiles the file. For a program that small, compilation is fast enough that you don't see it happening. Okay, that's integer overflow. So you have to watch out for this. Now, you have to be very careful about this. So the implication of this is that whenever you do arithmetic with ints, you're always worried about overflow. So for example, suppose I want to compute the average of x and y, right? So if you compute it as follows, int sum equal x plus y, return sum divided by 2, right? That looks reasonable, right? Looks reasonable. So let's do x equals 1, y equals 2. So the average should be 1.5, right? So let's see. Line average xy. Good. Run. Away you go. 1.5. Right. Looks good. Right. You know, if you were a little more careful, you might test this with more values. But there's a pretty good chance that you would never use really, really big values. So if x and y are the same, I'll get to you in a second, Mohammed. If x and y are the same value, the average is the same, right? So if x and y are 2, I should always get the same answer, right? So it's 2. So what if I use integer max value? Right. I know mathematically the average of those two values is integer max value, right? They're the same value. You're going to get a negative number down here, -1. That's not right, right? It's not right at all, right? And so the reason it's not right is because that sum overflows, right? Max value plus max value exceeds the range of max value. So it overflows. So the answer is wrong. The intermediate answer is wrong, right? The sum is incorrect. So when you take the average, it's also incorrect, right? So students, when you see this for the first time, you might say, well, I'll just get rid of the variable sum and compute x plus y. And say, well, that'll fix it, right? Because I'm dividing by a double. So when I take this value here and divide it by a double, I should get a double and everything should be fine. If you run that, you'll quickly realize you're wrong, right? You still get -1, right? And so the solution here is you must prevent that sum from overflowing, right? And there's a bunch of ways to do it, right? One of the ways to do it is to convince Java to compute the sum using doubles, because the range of double is much bigger than the range of int. So if I can coerce or convince the compiler to use double instead of int to compute the sum, this whole problem goes away. Oh, let me show you another thing that students will often write: double sum of x plus y. Okay, and so the line of thinking here is, well, I've got a double variable sum. So when I compute x plus y, it'll compute it using double arithmetic, right? No, it does not, right? It doesn't work. So when Java sees an expression like x plus y, the way that Java evaluates the expression is it says, what is the type of x and what is the type of y, right? So x is int, right? Y is int. So when Java evaluates x plus y, it uses int arithmetic. right? If x and y are very large, that sum overflows, and then the overflowed value gets stored into sum, right? So this doesn't work either. What you need to do is you need to make sure that this sum is not computed using int arithmetic, right? You have to convince Java to use double. So the easiest way to do that is to write that. Okay, so 0 plus 0.0 plus x plus y, right? And now why does this work? So this works because the plus operator has what's called a left to right association, right? In other words, when Java sees a bunch of plus signs, right, a bunch of sums, it evaluates the sum left to right. Okay, so it sees 0.0 plus x, right? And so Java says, how do I compute the sum? Well, that's a double, and that's an int, right? So the rule in Java is it will always, if it has two different types, it will use what's called the wider type. So double is the widest primitive type, right? So when it sees a double plus anything, it always computes this sum using double arithmetic, right? So that'll be evaluated as a double, right? And now you have a double plus an int. So Java says, well, I've got a double and an int, so I have to use double arithmetic to evaluate it. So this entire sum gets evaluated as double. And then when you divide by 2, you get the right answer. There you go. And that is the scientific notation for that. But they're equal. All right. So you have to be a little bit careful. If you've done the assignment, make sure it doesn't overflow. Right. One of the methods asks you to compute the average of 3 values. Right. Make sure that the sum does not overflow, because otherwise you're getting the wrong answer. Okay. Can you just call average without calling week 2 here? The answer is yes, Drake. You can do it here because I'm inside the class week 2. So if I'm inside the class week 2 and I call a method, I call a static method. I don't need the name week 2 in front of it. If I'm not inside the class week 2, so if I'm inside another class, then wait, sorry. Oop. Int. Right? Then I have to use week 2. So if I don't use week 2, it's going to complain. Right? It's going to say, I don't know what average int is inside also week 2. Right? So now you have to tell it, oh, look in the class week 2 for that method, and everything is fine again. Right? So if you're inside the class, you don't need the name of the method. You don't need the name of the class in front of the method. If you're outside of the class, you need the name. Let's see. I'm confused when you name the method public static double. Does it return a double? Yes. So public means any class can use this method. Static means it belongs to the class. So you have to use you're supposed to use the class name in front of the method. Double means it returns a double. That's what it means. If this is an int, it would return an int. So you'd have to use int arithmetic inside the method. And there's no good way. How would you do this? You'd have to think about how you would do this if it returns an int. So what's the difference between declaring a variable using int versus integer? Okay. The difference is Z2. So when you write int z equals 1, 2, 3, 4, right? You are making a primitive value z, that stores the value 1, 2, 3, 4, right? When you use integer, you're making an object, right? So you now have a reference variable. So Z2 is now a reference variable. So Z2 now refers to some object that represents the value 1, 2, 3, 4. So this is this is equivalent to the Python expression Z2 equals 1, 2, 3, 4. Right? This one makes an object. This one does not make an object. This using arithmetic is a lot slower than that. Right? It's slower because Java has to now access the object to get the actual underlying int value to do the arithmetic. Here, Java has automatic access to the value 1, 2, 3, 4. So in general, you should use the primitive type when you can, instead of using what's called the wrapper type. Right? Everything still works. So it's unfortunate that you can treat variables of type integer, big I integer, as though they were primitive, right? So I can do something like system out, print line Z2 plus. Right? This looks like I'm adding 2 ints. It works, right? It will in fact print out 1, 2, 3, 9, right? Unfortunately, what's happening here is that's an object, that's an object. So when Java sees this expression, it has to ask this object for the int value 1, 2, 3, 4. Then it has to ask Z3 for the int value 5, and then it can add them together using int arithmetic. This is way slower than if Z2 and Z3 were ints. Right? And by way slower, I mean a lot, like orders of magnitude slower. It's a lot slower. Right? You generally want to avoid using the wrapper classes to do arithmetic and things like that. You'll see later on we need them for some. We need them when we work with Java collections. Okay. But whenever you're doing arithmetic, you almost always want to use the primitive types. Okay, that was actually a lot longer than I was expecting. Anybody have any questions about any of the week 1 or week 2 material? If x equals, well, there's one. If int x equals 1 and x equals x plus plus is 1, why does the explanation is in the notebook answers, right? If you, Keithana, if you look in the, sorry, why don't I show you? This is probably, yeah, sorry, I have to reload the notebooks because I'm looking at the online version. How do we run the unit tester? Oh, yeah. So if you downloaded the assignment before I changed it, you ended up with a bunch of unit tests. They won't really work, but I'll show you how to do it in a second. Here, exercise solutions, right? All the solutions for all the notebooks are here, right? So part 2, hello, here. Part 2 exercise solutions are there. Part 3 exercise solutions are there, right? It's all here. So I'm pretty sure that question has an explanation. I now have to find it, which is going to be a bit of a problem. It was in the arithmetic notebook, right? Pretty sure. Sorry, there were a lot of questions and answers. So there's a lot of answers. Where to go? Control F. Where are they? Strange or true? Did I not put the answer here? Oh, here. Oh, I didn't give you the explanation. I'm sorry. All right, I'll explain it. Next assignment based on week 1 or week 2. So it's going to be. That's a good question. What am I having you do? So I forget what I'm having you do this week. Here's week 1. Week 2 is arrays. Good. And loops. Are there loops? Where's the loops? You need loops. So it's yes. So it's going to be week 2 and the first part of week 3. Okay. So question. This is a good question. So the short answer to this is never do this, but the explanation is as follows. X++ means take the value of x it means use the value of x. Okay, so that's going to be a 1. Plus x means increment the value of x and then use the incremented value. So x is going to change to 2, so you're going to get 1 plus 2, and that'll be 3, right? And then that's it. What do I get? 4. And then, yeah, sorry, x plus plus means use the value of x, and then afterwards increment the value of x. Right? After you've used it, increment the value of x. Plus x means increment the value of x and then use the incremented value. Right? And so when you add that all together, you end up with 4, which is weird. Right? The answer, so here, the lessons of exercises 8 through 11 is that you shouldn't do this. It's too confusing, right? It's way too confusing, right? It's, yes, it's nonsense. You will never be asked this in this course, right? I will never give you a quiz question that says, what is the value of x, right? It's way too confusing. Is it okay to use, yeah, of course it's okay to use x plus equals 1. It's not messy at all. X plus plus returns 1. Yeah, so when you evaluate this expression, it's 1 plus 2 is 3, stores that in x, and then increments x, so it's 4. It's way too confusing. Anybody who writes code like this should be shot, so don't do it. Anything else? Oh, how do you run the JUnit tester? Do I have, trying to think if I have anything. So the version of A1 here does not include the tester, but I can make one for you. New JUnit test case. We're going to look at this later on in the course, so don't worry about this if you don't know what's going on. Okay, I'm just going to make a test that tests maxint. No, let's do something else. Let me test remove last 2 digits. That's a good one. Wait, so remove last 2 digits. Okay, so all right, so I'm going to remove the last 2 digits of 1, 2, 3, 4. So the expected answer is going to be 12, right? A1 remove last 2 digits from 1, 2, 3, 4. Assert equals expected. Okay, so there's a little JUnit test case that's going to test this method, remove last 2 digits. Right? If I run the test case, either have it open in your editor and press run, or over here, right click and run as a JUnit test. Right? It doesn't matter, either one works. If I run this, it's going to fail because this is always returning 0. Right? Over here, it says I expected 12, but I got 0. So you go back. Oh shoot, sorry. So once you've got that test telling you there's a problem, you go back here and fix the method. So I'm going to return 12. Run the test, and now it passes. The method's wrong though, right? Yeah, the answer is obviously not 12, right? But that's how you run your JUnit test case. The test cases you have are for a different version of the assignment. So there's a bunch of tests that won't work, which is why I didn't realize I had released the test cases along with the assignment. The updated version of the assignment doesn't have the test cases. I'm not sure the test cases. So the test case, when you run the test cases, you're going to get a bunch of red X's because there's a bunch of methods missing. To remove the last 2 digits of a number, you just divide by 100. Right. Et voila. That's it. Okay, for the age problem, I struggled understanding the point of it. Yeah, it's just showing you how to do successive. That's exactly what it was. This problem here is just a silly little problem that forces you to do some arithmetic. That's it. That's all it is, Mohammed. There's nothing sophisticated about it. I mean, if you want to, you can work through the algebra that proves that this always works. Does it matter if it? Yeah, don't worry about overflow and stuff like that. I'm not going to test that. right? There's conditions in the method, right? It says it only works for people in that age and for I deleted the number. There's supposed to be a number here. That's hilarious. It only works for addresses up to some number, right? Don't worry about overflow. Any other questions? I think I got them all. JUnit difference between, yeah, got that one. Yeah, okay. Anything else? If there's no other questions, that's it for today. I'll post the PowerPoint and the video in a couple hours. Can we see your cat? I can show you one cat. The door is closed because that is because of one, cats, and two, my partner's in the other office doing some work. Let's see, what do I need to do? I need to turn on my camera and stop sharing, right? Okay. Camera? Oh, wait, is it working? Camera, hello? Is it? Yeah, okay, there I am. Okay. There she is. That's Ivory. Not our cat, actually. That's our cousin's cat. We're taking care of 3 of her cats. Hang on, let me, come here, Ivory. Yeah, come here. There we go. Oh, class wants to see you. There you go. Say hi. There you go. Right, there's another 4 of these things kicking around the house. There you go. Yeah, so I'm currently taking care of 5 cats. Yeah, so normally I keep the office door closed when I'm doing this sort of thing. Okay, any other questions? All right, that's it for today. I'll see you next week.